This is a production of Cornell University.
So I'm Valerie Manson. I'm from the University of Florida, and as my introduction said, I'm the agricultural sciences librarian. Since 2009, I've been involved in a project, an ongoing project that supports the faculty reporting to the USDA and specifically NIFA for the Institute of Food and Agricultural Sciences, which I'm going to call IFAS. IFAS has more than 600 publishing researchers spread across 28 units. They actually have more like 900 faculty. And every year they report their scholarly refereed publications to the USDA NIFA in compliance of the AREERA Act of 1998. In 2008, IFAS began this. They actually switched from a homegrown system to using EndNote Web. They had a meeting. Yeah, I see a scowl. Why would you use EndNote Web? They had a meeting with the dean, and the dean left the meeting saying they would test EndNote Web, and then promptly sent an email out to all faculty saying faculty reporting is in EndNote Web. So that was in 2008, and they had an IT guy in IFAS providing the support for that process. It took them all of a year to decide that this was beyond their capability, that they were going to lose an IT guy very quickly if they didn't find a different support model, and so they signed an MOU with the libraries in 2009. Just to give you an idea, I'm discussing some things in the presentation, but in the paper, I give you additional background, some roles and timelines related to the data project, a detailed data collection workflow, some of my challenges encountered, and then the analysis results and the challenges involved in the analysis, and then of course future directions. Today, I'm going to talk about the data collection workflow because I'm just going to assume that many of you haven't done this sort of data collection, and so that would be the primary topic of interest. And then I talk about my challenges, and then I talk about the directions that I'm going to take in the future. So this is where I talk about the workflow, and it really is sort of a puzzle you put together. There's a lot of different pieces, and knowing which order to take in the collection, in the analysis, in the standardization of the data, you have to work it through and plan accordingly. So the workflow has roughly 5 different steps or different phases. And the first is to develop the support materials and your timeline. Second is self-reporting. That would be your faculty reporting. The third is the unit reporting, because the way that we collect the data, I'm not collecting the data myself. The faculty are collecting their own data. They are reporting their publications. Those reports are compiled into a unit report where a unit coordinator in the IFAS unit is managing that particular process, and then it comes to our report coordinator within the libraries, and that's where it hits the unit and master list processing. And then lastly, we have a standardization and analysis workflow, which is new. So I'm going to talk about each of these steps and who takes care of these steps, and I can answer any questions at the end of the session, I believe, if you have any questions about any particular area. So who exactly is involved in the support materials? We have to get IFAS administration on board with this. It's a very, this is an initiative that started in their administrative office, and so we have to have their heavy involvement. I involve them in hiring my annual report coordinator. We develop the timeline together. We review they do not review and update print guide. The report coordinator and the librarian, which is me, reviews and updates the print guide, the video tutorials which we have created, the support web pages. We create in Google Documents spreadsheets which help us document all of the questions that come from faculty. This helps us improve the process for the next year. And then we outline a communication plan, which in the beginning just we created an email, we sent it to unit administrators, and over time we've realized that we had to develop better communications and strategic communications. And then we kick it all off with an email from IFAS administration, an official email from IFAS administration, outlining the very general process, what the primary purpose is, and then we follow up with the report coordinator, and I work on support emails to the faculty. So the self-reporting is probably it takes the longest amount of time. We start in December. It is faculty, publishing faculty within the 28 IFAS units. They populate their EndNote web folder with refereed publications. Once they have their citation, they include a refereed tag in one of the fields in their citation, so that's the type of work field. We include a required, we have about 6 fields that we require that they fill out. That includes the title of the article, the source, the author information, a DOI if available, and we then have the faculty share their folder with the unit coordinator. Exporting from Web of Science, some faculty are comfortable with that, but the majority of faculty actually hand enter their publications. Now this isn't ideal. This isn't the way that we want to do the publication reporting, because as you can well surmise, the data isn't as clean as we would like, and we'll get back to talking about that when I talk about the standardization. Once the unit faculty have inputted their publication or exported it from Web of Science or CABI or whatever database they've used, they then notify the unit coordinator, who is sort of a unit secretary for their department, that their folder is populated. The unit coordinator then accesses all of those folders within a shared function within EndNote Web. The unit coordinator accesses those folders. They compile a unit list. They remove any duplicate publications, there are a number of duplicate publications, because as you can imagine, when somebody writes an article in, say in Animal Science, they often write that paper with a colleague, so there's a lot of duplicate publications. They review for accuracy, which is a step they sometimes skip, and then they share that unit list with the reporting coordinator, who is the employee in the libraries who manages this process. So that's early February. In late February, the reporting coordinator then works within each of these unit folders, still working within EndNote Web. They remove any lingering duplicates. They review some of the citations for accuracy. So if there's misspellings or author information that isn't completely filled out, they might add that information. They then compile a list of all of the publications for all of IFAS. So they take all of the publications within each of these unit folders and they compile them into an IFAS all master list. They again remove the duplicates and they submit both the unit publication, the tally counts, and the unit citations, as well as a master list of counts and not citations, to IFAS administration. Okay, so we work both in the unit level and the IFAS level. So the next step that we have added in the last year was a data standardization step. And this is, the overall purpose of this is to showcase the data. So the data that we've sent to IFAS administration, which are the tallies of each of the units and the IFAS all master list, that's really for reporting to the USDA. Once we hit the data standardization piece, this is for showcasing within the University of Florida. At this point, we don't send this data to the USDA, excuse me. So what we do for the data standardization, and there are a lot of steps involved in the data standardization, and this is where I get involved quite a bit more heavily. As the librarian, the coordinating librarian, data standardization isn't something that's easy for us to do. So you can just imagine that if you've hired a reporting coordinator, for a limited period of time, that they're not going to be comfortable sanitizing data. And I would say that thanks goes to Cornell for introducing me to Google Refine, because that's the tool that I've used for a lot of the data sanitization. We export the data into Excel, and I do a quick capitalization sanitization. So many of the faculty type in their publication information in caps lock. And Excel has a pretty easy way for changing the capitalization, with a click. So I push it into Excel, I change the capitalization, and then I export it into Google Refine. Google Refine is an application program that you download. It works directly in your browser. It's very easy to use. They have excellent video tutorials on the tools and features within the system. And what I do is I go in, I create uniform source titles. So if I have Journal of Animal Science and Journal of Animal Sci and J of An Sci, I make those all the same title. And Google Refine makes that an extremely fast, efficient process. I thoroughly remove the duplicates because using EndNote Web isn't the most ideal way to remove duplicates, but Google Refine gives me a very easy way to remove them. Incorrect data in different fields appears in Google Refine. So if you have the volume and issue information in parentheses next to a title, I see it. Just by looking at the screen, it pops out almost immediately. And then, of course, I create additional tallies or counts, which I do send to IFAS administration. So that's my workflow. So if you have any questions, I can talk more in depth about any of those areas. There are a number of challenges with the process, and not the least of which are tool limitations. As you can well imagine, using EndNote Web. EndNote Web is an excellent product. I use it for bibliographic management software, bibliographic management within my own research and publication history, but it's not designed to be a tool that manages large volumes of publications. It's not designed to be to give you the ability to edit large numbers of citations at once. It's glitchy, I will say, as well. So in some cases we had, thank you, we had an EndNote Web folder that was shared with a unit administrator, but that folder wasn't sharing, and we have to call EndNote Web to have the technical support. So maybe 5 or 6 times I called EndNote Web every year for the last couple of years to have a glitch fixed. We also used Ulrichs to identify whether something is refereed or not. And Ulrichs isn't always accurate. Let me go on. So I'm talking about the challenges. Also, one of the other challenges is that faculty sometimes don't use EndNote Web except for this one process, and being an occasional user, it's very frustrating for them. As I said, they manually input. Folder sharing is not necessarily intuitive with the technology, and as I said, glitches. There's also a number of challenges with user perceptions. As any kind of work is, if faculty are asked to do this sort of a process, they inevitably see it as an evaluative process. And I can't necessarily argue with that, because we are using it to evaluate units. It is not used to evaluate individuals, but when I say we, I really shouldn't say we. The libraries are not evaluating them. We are merely supporting a process that exists and supporting IFAS in that process. So we have to continue to be neutral and supportive and communicate that we are a support entity and not an evaluation entity. Refereed or not refereed, faculty have a difficult time of understanding sometimes what is refereed and what isn't refereed. So I actually don't remove any refereed tags unless it's an extension document. If it's coming out of IFAS as an extension document, I will remove a peer-reviewed tag. 1 minute, okay. Communication, as I said before, it's an unpopular process. We have to be careful with our communications and all-inclusive. We can't just email unit admins. We have to include everyone. We provide thorough support materials, and we don't make long deadlines because they don't always work. And we provide support and incentives for departments who finish early. We do a lot of the work for them if they get us their publications sooner. And then future directions, we want to improve reporting, support showcasing and metrics while staying neutral, expand analyses to SACS accreditation reviews and to benchmarking requests, and then of course to improve library collections and services. And I'm not going to go into detail on the library collections and services at this point since I'm running out of time. And then of course, questions at the end, and I would just like to say thank you. And I live in Florida. If you're ever in Florida, this is Ichetucknee Springs. It's one of our cold water springs, 72 degrees year-round. If you're ever in Florida, please drop me a line. You are more than welcome, and I would love to take you to one of our springs. Okay. Thank you.
Hi. So this project is a little bit different in that instead of talking about a particular workflow or talking about how I would manage data, it's trying to see what needs there are and what's currently happening by examining current products and workflows that you can see within this organization. So, this is all about the Coral Triangle Initiative, which is an organization that is built by the 6 nations, Malaysia, Indonesia, Timor-Leste, Philippines, Papua New Guinea, and the Solomon Islands. And the point is to have a multilateral approach to protecting the coral reefs and fishery management and creating sustainable food sources and biodiversity in the region. So as you can imagine, data is important for this entire process. So the Coral Triangle Initiative, in order to create a framework for the work that they're doing, has established these objectives, which is to strengthen the management of seascapes, promoting ecosystem approach to fishery management, establishing and improving effective management of marine protected areas, improving coastal community resilience to climate change, and protecting threatened species. I think the important thing here is how interdisciplinary all of these aspects are, in that you can't take data from one particular discipline and expect it to do what you need. So, in examining this situation, I thought it was important to look at the data and the decision-making tools that the Coral Triangle Initiative is promoting within their, to the managers of the marine protected areas. So they have 3 programs that they really try to push, and this is FishDA, which is a decision support system that tries to integrate fishers as well as other stakeholders in the process. TURF, which is a program that looks at that looks at resilience of the ecosystem and of the community, and then Coast Plan, which is also another one that looks at trying to make sure that the wildlife is preserved and the ecosystems are preserved. So what's interesting about these is that each one of them states very clearly that the data needed to complete this form or this program is easy to use, that it's easy to obtain. They also note that data, like accurate data, is important because otherwise it will affect your results. And finally, that missing data shouldn't halt the planning and implementation of your marine protected area. So there's a nice, dichotomy going on where, yes, we need data, yes, we need important, accurate data, but at the same time, if you don't have it, don't worry about it, move on. So the other part of this is, in order to make it easy to use and allow any manager to use these programs, then they expect data sources to be particularly easy to obtain. So they suggest interviews with stakeholders, using maps to figure out exactly what your municipal waters are, and then going to the local government if they happen to be keeping data on the types of fish that are being caught or the price of fish, etc. So all of this brings up the question of, why isn't there more data about the Coral Triangle? It is a hotspot of biodiversity. There are, about 60% of the world's known coral species are have lived within that area. So, in doing a quick search of ProQuest, you can see that, searching just for Coral Triangle and fisheries leads you to 741 hits just for articles in the past 5 years. And of those, only about 100 of them are refereed. But still, it's evidence that there is research going on in the area and that work is happening. So then the question is, first of all, is it usable? And second of all, where is this information? So the usability comes down to a couple of problems. First, there's the licensing issues of peer-reviewed journal articles. And second is whether or not you can actually obtain the data from that was used in those research articles. So here is just a snapshot of different providers of data that cover the Coral Triangle. You can see there's a huge variety of different organizations that are producing huge amounts of information. A lot of them are they're not confined to just the Coral Triangle. They, like USGS and FishBase and NOAA, are doing a lot of international, like their satellite information, and so it's a global. But nonetheless, some of them have products to do with the Coral Triangle, and otherwise you can always refine and just look for, or just get data for the area that you're interested in. So of those, there are a number of different types. These, for example, are socioeconomic data sources, and they vary in the types of data that are available in them, between journal articles and reports to GIS data to like looking at the night lights of the areas and being able to figure out urbanization and wealth from the night lights, which is the DMSP OLS. Then there's also biodiversity, and these tend to be repositories in which scientists will report their observations for whatever research they're doing. So they're amazing resources in that you can get a lot of information from places and not have to do the research yourself, which is really expensive. But on the other hand, it also means that you are beholden to whatever area is most popular. So if wherever you live is not being researched heavily, even just within your own cove, then you're not going to get the data that someone else is going to get. And then there's biophysical, which is kind of an odd term, but it encompasses both things like phytoplankton and sea surface temperature and all these oceanic types of data that's important for understanding the health of the coral and whether or not diseases are going to occur and things like that, what kind of pressure it's under. And these tend to be satellite data, and so they happen regularly. You can usually get near real-time information out of the products. Anyway, but then they are about this one particular area of the field. So what we end up having is that there are a lot of different types of data over a huge variety of subjects. And if what you're interested in is the interrelationships between the data, then it's really hard to get at because each one of them is using a different metadata schema. Each one is using a different portal in which you can access the information. The one thread that seems to be current throughout all of them is the use of geographic data, and that most of these data sets use this as a way to collate the information. And so even though you can't completely integrate the different data sets, at least you can create GIS maps with different layers that can then lead to correlations, or at least relationships. I keep doing that. So one way that the Coral Triangle Initiative has gotten around this is through the Coral Triangle Atlas. And what it's done is essentially created these different GIS layers so that they can produce a product that has very diverse types of data sets within it. And it serves not only to be a visualization of the problem or of what's going on in the area, but it also becomes a portal to other sources, which is really important because otherwise you're going to each individual organization's website and trying to pull the data set from NOAA or from the UN or from whoever happens to hold the information that you're looking for. So they create a portal that helps with discovery of this information. And they have these interactive layers so you can play around with the different factors that are affecting the area. In addition, they also hold some raw data sets that they've been allowed to have. But the potential drawback from the Coral Triangle Atlas, even though it's a wonderful tool, is that they're not as up-to-date as the original source would be. So where NOAA would have information from 5 days ago, they're going to have information from last year. I'm going to keep doing that. So then another approach that uses this trying to integrate the different sources of data is through data modeling, in which you try to determine predict the course of events based on current factors. So in looking at reefs at risk is a widely used study, and they in fact have their data sets in the Coral Triangle Atlas as well. But in order to get around the socioeconomic data problem, in that it's not treated the same way as satellite data is because it doesn't have the same pixels and the same it's not the same type of data, then what they've done is they've created threat levels, essentially. And so they will build an analysis of the threat to, based on like coastal construction. So the number of hotels, the treatment of sewage, the water flow, things like that. And then build a threat level that they can create a polygon for. And so then they can overlay that on the mapping system, and then just have the satellite data on top of that. So that's one way to get around the issue of having information that is not always interoperable. And so their program is based off of threats. Their entire model is based off of threats and then the current status. So current data curation practices have led us to a certain situation, which is in many ways wonderful and amazing. So first of all, it allows us to conserve this data and it gives it context and structure. But at the same time that it's doing this, because the schemas are so dependent on the needs of the individual disciplines, then it makes it harder for them to talk to each other. So what you have to do is move beyond the individual fields and create crosswalks or other forms of interoperability, which is what we saw with the Coral Triangle Atlas and with the reefs at risk modeling, in that you have to find ways, and those are both relatively crude because they're not actually integrating the different types of data sets. However, the other side of this is that if you expose it correctly, then you can, it leads to discoverability to external fields. So what does all this mean for data curation in the Coral Triangle? Part of it is that with this type of work, then you're dealing with limited resources because, you can't spend all your resources on data curation, for example. And so accessing available resources is complex due to the sheer variety of what you're dealing with. And so while the actual data may be free, the process you have to go through to actually get it will take long enough that it's no longer free. It takes a lot of resources. And then, depending on the type of data you have and whether or not you're working through a portal or whether or not you can actually download the entire data set, it's going to require varying levels of expertise. And so this can require training or can affect their ability to even access the data. So then the next question comes, what can we do to shape the data landscape of the Coral Triangle? And part of this has to do with the discoverability of the data, the challenges of interoperability, and then making sure that local survey data is actually curated. So the discoverability can come from a couple of ways. First of all, it could just be as simple as having a data catalog or putting RDF tags into the metadata in order to create a linked atmosphere. But of course, that requires everyone working together and doing the same thing. Otherwise, you're talking to yourself. The second thing is the interoperability. And once again, it depends on what resources you have at your hands. And so right now, they're essentially using geographic data tags as a way to make sure that you're talking at least about the same piece of land. But it can become, of course, much more complicated than that. And then finally, and I think this is the most important takeaway, is making sure that the local survey data is actually curated. And making sure it's discoverable and giving it context and making it interoperable. Because where we see that in their tools they want people to use local survey data, then you don't find it anywhere else. So it's pretty clear that unless it could be hiding somewhere, that it's being put into these programs and then being used for the one model and then disappearing instead of, curating it and making it into an actual product that can, grow and sustain and talk to other or be interoperable with other sorts of data sets. That's. Thanks.
Right, so my name is Bree Feingold. I work on a program called Plantwise, which is a global program currently working in 31 countries, aiming to support food security by making sure that smallholder farmers have access to the information that they need to be able to manage the pest and disease problems that they have. So we do this in a couple of ways. There are three main pillars to the program. One is plant clinics, where we work with already existing extension services. They might be government extension services, they might be NGOs with extension remit, some universities as well. Anyone who is in the business of giving advice to smallholder farmers. And we provide training and help them set up plant clinics, basically taking the information that they already have, the knowledge that they already use in their day-to-day work as extension officers, and then combining that with some sort of rough and ready field diagnosis techniques so that they can set up these plant clinics, which can be as simple as a table in the marketplace. And farmers can bring the crops, they bring samples of plants that are affected by pest and disease problems. The plant doctors that have been trained in Plantwise tell them what's wrong with it and what they can do about it. Strengthening plant health systems, I'm going to come on to in just a minute here, but it's basically about strengthening communication and collaboration between all of the different actors in the countries that work on anything to do with plant health, whether that's from providing advice to farmers or doing research or regulation or anything like that. And then the knowledge bank is the bit that I work on, which is a global database that has two bits. The open access side brings together scientific knowledge from all around the world, all sorts of sources, about plant pests and diseases, and provides easy-to-use tools for diagnosis, information about treatment, mapping tools, basically as a plant health information resource to be used by all of these actors in plant health systems. And it also provides tools for managing data that's collected at the clinics. Because in addition to providing fact sheets and other extension materials to the plant clinics and other frontline extension workers, the knowledge bank also collates and organizes and manages and analyzes data that's collected at the plant clinics by the plant doctors. So when a plant doctor is giving advice at a plant clinic, they are also collecting information about the crop that's been brought in, what they've diagnosed on it, where it was, where it's come from, the advice that's been given, and that sort of thing. So the knowledge bank is basically a data and information management system that manages both extension material and other plant health information resources and the data that's collected at the plant clinics. On the strengthening plant health system side of things, like I said a minute ago, it is basically about getting all of these different actors who are involved in anything to do with plant pests and diseases, and getting them collaborating and communicating better. And information is really, really central to that. And we see the clinic data is really important to that. So the plant clinics are basically an entry point to building partnerships with all of these different actors, getting them talking, getting them sharing information. And the data that's collected at the plant clinics can be used to help the extension people orient their priorities for what they want to run awareness campaigns on. It can be used to help the research people decide what their research priorities are. It can help input suppliers decide what they want to have in stock. It can help the regulatory bodies know what they need to be doing their surveillance on. And the reason that the farmers are at the top of that diagram is because the entire point is the farmers and improving the service that they receive from all of these people. So having the information that we're collecting at the plant health clinics and sharing it around between all of these different actors is really key to that. So basically all you need to do to get that is get a couple of thousand plant doctors who work for a couple of hundred different organizations in a couple of dozen countries to collect data on the interactions that they have with hundreds of thousands of farmers, and you organize and store it and manage it and analyze it, and you're all set. Right, so this is obviously massively challenging. There are a couple of different kinds of challenges that we run into with it. One is political challenges. Data and information on plant pests and diseases is highly sensitive because it's a trade issue, especially when it's quarantine pests involved, and especially if things turn up at plant clinics that haven't been previously reported in that country. Because it's sensitive, and because of the amount of work that's required from the people that are involved in this system, partnerships are really, really key to it, and involving the people who are going to be involved in working on all the different aspects of it from the start is really key. So a couple of ways that we're dealing with this. We have policies within Plantwise on things like reporting pests. We don't report pests that aren't already known to be in the country. Things like intellectual property, who owns the data, what can be done with it. Things like how do we handle personal information of all of the farmers that we're collecting data from, that sort of thing. Data agreements with the governments in the countries where we're working and with the organizations where it's non-governmental organizations that are involved in running plant clinics, laying out what can be done with the data, who can use it for what, that they're happy to help them manage and hold it, and whether they are then also happy for us to use it for other purposes or whether they want to keep that restricted to use within that country. And then secure systems, obviously the online databases that we're building to manage and store this information have to be secure. In terms of practical challenges, there are lots of them. A lot of the countries where we're working, infrastructure is poor, connectivity is poor, capacity to use anything from a computer to any of the other tools that we're using really depends on where you are and who you're working with. Coordination can be quite difficult. In some countries, the clinics are mostly all run by the Ministry of Agriculture. In some countries, you've got a couple of dozen organizations within that one country that run clinics. So how do you coordinate that? Who is in charge of it? And as Valerie found in her kind of different context, but actually very similar story, incentives are really, really key to all of this. Why would people put all the work that's involved into capturing this data, getting it back, organizing it, managing and using it? And one of the things that we found, kind of getting slightly ahead of myself here, is that the data itself can be a really, really good incentive. And now that we're at the point where we've got data back from several of the countries and are able to start showing people the kind of things that you can learn from the data that's being collected at plant clinics, they're getting much more excited about it, and everyone really wants to have the data so that they can start using it. So to start off figuring where are we going to go with this, we set up a theoretical workflow of how we think that it would work to get this data back from the clinics and get it into use. So we've broken it down into a couple of stages. The groundwork stage is mostly about building the partnerships, building the trust, getting data agreements signed, but then also figuring out logistics of how do you, where can you get the forms printed locally that we're collecting this data on. The recording stage is where the plant doctor records the information at the clinic. Transfer stage is about how do you get the forms back from the clinic, either in hard copy or digital form once they've been filled out. Data entry is how do you get that onto the computer. Harmonization, we've also been using Google Refine. If you have forms that are coming back with oranges and orange trees, you want that turning up as one crop, not three. Validation, how confident can you be in the things that the plant doctors have diagnosed? Do the symptoms match, for example, the diagnosis is on the paper? What kind of analyses can you do with it? And then who within the plant health system needs this information? How does it get shared around? So having come up with the theory of how we think it should work, how we want to go about it, we figured we'll do a trial in one country first and see how it works as an end-to-end system. So we did this in Kenya in partnership with the Ministry of Agriculture there. We've been working with them very, very closely in Plantwise, and we've been talking data with them from the start, and they're quite keen to get their hands on the data and start learning from it and start integrating that into the work that they do. So we've got a data agreement with them. They set up a member of their staff as the national data manager for the country who's in charge of the whole system and process. They've set up a data center within the ministry, a couple of dedicated data entry clerks, and we basically went through with them the entire stage of that workflow and discussed what the best way to go about each of the boxes on the workflow is. How do we want to get the forms back from the clinic once they've been filled out? Whose responsibility is that? What resources do we need to make that happen? So they've got the way that they've organized the plant clinics in Kenya is around hubs, which is basically on a district basis. So we did the trial at 35 clinics in the 15 hubs. There are now just over 50 clinics in Kenya, but at the end of last year when we did this, it was 35. And for the most part, we came up with one way when we were talking with the ministry about how we want to go about each of the stages. For the jumping, can I jump back? Yes, I can jump back. So for the transfer and data entry stage, there were a couple of options, and we figured we would try both of them and see how they compared. So in 5 districts, we did a pilot with scanners and text recognition software to see if we could automate some of it, take some of the work out of it. And in 10 of the districts, it was a question of getting the forms back to Nairobi using couriers and typing them in at the ministry. And the way that we allocated districts to the trial was basically what kind of infrastructure do they have there? Do they have a computer? Do they have electricity most of the time? Do they have a modem like a 3G dongle that they can use for internet at the hub so that they can send the scans back? And basically what we ended up finding was that again, similar to what Valerie found, where the slightly more elegant solution isn't necessarily the more robust one. None of the hubs that we're trying to scan were able to actually make it work. But all of the hubs, including the ones who had initially been trying to scan, were able to get their data back to Nairobi and get them entered manually with the manual data entry in the ministry. So at the end of the 3-month trial, we had over 400 records back in the database, and the ministry decided that the way that they wanted to continue doing it was with the hard copy process, where they get the forms back via courier and enter them there. And yeah, they're very excited about the data, and they're really, really keen in Kenya on what they can do with the data now. So they've set up a national data validation and analysis working group, and are starting to look at what they can do with this data now, and all of the work of all the different actors in the plant health system. Some of the things that really, really stood out is that it's important to begin discussing data from the start. When talking about the program, it's not a question of going in and talking only about the plant clinics, but also about what we can learn from the plant clinics and what we can learn from having well-collected, well-organized, well-managed data that then feeds into the work of all of the different actors in the plant health system. And that working with local partners is really, really key on coming up with a way to do that that's going to actually work, both because you need the political buy-in, they need to want the data, the incentives need to be there, and because you don't want to end up setting up a system that's not going to fit into their workflows. So it worked really, really well working with the ministry in Kenya, basically to decide how they wanted to go about each bit of it. And From there, we took the experience from Kenya and the lessons that we learned in that pilot, basically as a template process for how to set this up in other countries. So we've put together data management training materials for CABI staff that are involved in Plantwise and also for our in-country partners. We're doing training in data management for all CABI staff that are involved in Plantwise this year, and we're doing in-country training workshops as well in, I think, 13 of the countries. Kenya data's coming back regularly, they're processing it, and are moving on to looking at how they're going to validate the data, and then getting the analysis and sharing set up and working. And we've rolled the process out now to several more of the Plantwise countries and have almost 12,000 records in the database. So it's certainly not easy, but it's very much worth it, and it's very exciting to see what kind of uses people are starting to come up with for the data and how they're going to be fitting it into their workflows. So, yeah, that's cool.
So we have time for questions. There's a microphone right here. If you could please step up to the microphone.
Hi, Federico from IAALD. Cambria, this is very interesting, and the approach of the local providers of information through the use of some kind of expertise then goes to the national level to validate information. You said it's very sensitive, indeed, the data related to plant diseases, plant plagues. But you didn't tell us how does the Kenya government has taken it in terms of not affecting their trade, right? Either a farmer might not be interested to go to a plant clinic and say, oh yeah, I have certain disease that is killing my crops. While I might think also that the government extension officer might also be very selective on the things he will process and come back to his unit to say, okay, is this going to affect the trade of this crop or any other crops? So how does the farmer, or how you have convinced the farmers to approach the plant clinic, and then the government, how honest are they being with the data collected?
Are we answering questions one at a time, or collecting them? All right. So in terms, I don't know if this microphone is on. It is if I lean closer to it. Right. So in terms of who is concerned about trade issues, and in terms of who considers this data sensitive, it tends to not be the individual farmers, and it tends to not be the extension officers. It tends to be the central governments. So the farmers are perfectly happy to come to the plant clinic. They don't actually know what it is, and even if they did know what it was, they wouldn't know that it was a potential trade issue or quarantine pest. Most of the extension officers in most of the countries where we work also don't know all of the pests that are quarantine pests or not. In terms of how we handle the sensitivities around reporting pests and the trade issues of it, when governments and the organizations that run clinics sign up to the data agreements, they have a choice basically between saying either we only want this data used within our implementation of Plantwise in this country and it doesn't get shared publicly, or we're happy for it to be shared more publicly. So Kenya, for example, has only agreed at the moment to be sharing data within Plantwise in the country. They haven't agreed to any of the open access things. Other countries have agreed that it can be used in open access, so when we have enough data in, then we can look at, can we be plotting more local pest and disease information on the pest map and the open access bit of the knowledge bank. But even once we have that set up, we will never be reporting pests that are not already known, either officially reported or in the scientific literature, to be present in that country. So it's not a question of reporting new pests, that's not our job. How honest governments are about which pests they do and don't have really depends on the country. Some of the countries that we work with in Plantwise are very closed about what pests they do and don't have. Some of the governments that we work with are basically of the opinion that our trading partners will trust us more if we say, these are the ones that we have, because they'll know then that we're telling the truth that we don't have those other ones. So how much they want to share depends on the government, and we leave that to them really because it's not our job.
I just have a quick comment. The University of Florida libraries have been working with our plant diagnostic lab which is a new lab, and they do training, diagnostic training to the global community, but really more so for Florida and for the Caribbean countries. And they have data going back, I think, to the 1940s of plant diseases in Florida. And this data is written on pieces of paper, and they don't have the specimen pictures or anything, which they now take, but they have a lot of data going back historically, through history, and they're looking to store that data with the libraries. And one of the things that they're asking that we do, or rather, they're going to be submitting the data. They're taking out, they're using county information, but they are not using particular farmer or location information, so that they felt comfortable with county information, and that they felt that protects the farmers enough that they, people aren't looking at them, oh, you have that disease, kind of thing. So, I don't know, just a comment from Florida.
Yeah, definitely.
This is for Valerie. I'm just curious, you had a whole suite of outreach strategies for training faculty and to participate in this process. Which of those were most effective for you, and can you speculate as to why?
Really the one-on-ones. Not everybody needed one-on-one training, so it wasn't a real taxation, but usually if somebody was approaching us for assistance, they were frustrated, and so the report coordinator would go out and provide the one-on-one training at their office, and that seemed, or do Adobe Connect, like a little webinar with the people who are off campus. We provided some videos, like little Camtasia videos that were about 30 seconds long for some of the major issues, like how do you tell if something's peer-reviewed, how do you export, how do you export from Google Scholar, which Google Scholar, one of the data analyses that we're doing is how effective is Google Scholar? How many of the citations are there? So, it's a really easy process to export from Google Scholar. So is that something that we can encourage folks to use rather than Web of Science? One of the analyses that we did was which databases have the citations, because we've had is Web of Science something that is Scopus better? Is Web of Science better? There's this feeling in the departments that Web of Science is this amazing database, for agriculture, and the librarians are, well, it's not really agriculture, CABI's better. And so it's been interesting to see the results of that. But yeah, the one-on-ones.
For Jeanette, you had a whole set of challenges that you identified with diverse data and diverse data sources, and I'm thinking of that kind of classic project management triangle. You can have it fast, you can have it cheap, you can have it good, you can't have all three. Did you find yourself kind of prioritizing interoperability or access or ease of use to try and just get the job done? Which did you choose to emphasize?
I would say that given the focus of the organization, that getting it fast is what they want. And I'm not sure about the long-term effects of that, or whether or not it has to come from outside of the Coral Triangle Initiative for something else to happen. But it feels like right now, they're just desperate to get some sort of conservation efforts underway. And so whatever that may be is what they're doing.
Quick one, the threat-driven, I don't know, whatever you call that, typology for approaching the socioeconomic data, did you see that there were certain types of data that were disadvantaged by that threat structure?
It's really kind of specific. So it would be, the number of hotels that are so far away from the coast, and the number of tourist businesses that are so far away from the coast, and the idea being that which is problematic, in that any sort of construction is seen as being a threat, rather than trying to get a better understanding. Because also, like, the threat of any construction went down the farther away it was, depending, I mean, and so there's a lot of variables. It's a very coarse sort of scale, which they were very upfront about. But again, it's essentially this assumption that we have no information, and so you do what you can with what you have.
Join me in is that on? Okay. Please join me in thanking our speakers one more time.
This has been a production of Cornell University. On the web at cornell.edu.